Hello, I'm Lee Sanders. I'm a performance analyst working in the same UK team that's been developing the erasure coding. Um, uh, so, a couple of questions. Um, who does Ceph benchmarking in this room? Yeah, quite a few of you. Um, who has heard of CBT? Oh, okay, quite a few. Yeah, that's a good thing to hear. So for those that might have been at Ceph Day London last year, I spoke about an issue where Ceph benchmarking, depending on what you're doing, is done differently. That the issue with that is that is differently. I mean, is not done in a deterministic and consistent way. A lot of that is because the tooling around post-processing of performance data um, is is a little bit lacking in a few places. So what I'm going to present today is some improvements to CBT to improve the post-processing of performance data when you're benchmarking Ceph systems, such that you can, if you can improve the post-processing, then you can do your benchmarking in a consistent, deterministic way to produce repeatable and comparable results, and that would be across the community. So the vision for CBT is to produce a single click standardized test methodology across block, object, and file with comparable results in a repeatable and deterministic way, and also provide comparison tools so you can take one Ceph version and compare it to another Ceph version. So you can demonstrate the improvements, easily spot regressions. And we'd like the adopt this as the way of benchmarking Ceph across the community, so we can all compare results to get together. So some of the tools I'm going to show, what I've been showed you today is we've developed post-processing to be able to develop 30 plus hockey stick curves with a defined test order with a wide variety of different client-like workloads. We'll also use this so you can regression test a build in around about 12 hours, or you can do a quick 3-hour regression test. But so this is a change of direction for CBT. So CBT has largely been developer focused. So you've had to develop your own orchestration with CBT. So this is what's largely led to the inconsistent approach of benchmarking Ceph across the community. But we'd still like to maintain that developer focus by having the optional enablement of CPU utilization and co-profiling features. So yeah, the bottom 2 points is that we'd like to be able to share the results across the community by uploading all the results from CBT into a GitHub repo. I've had some feedback from various Ceph sellers that of lack of performance data to aid client sizings. And that's largely because with Ceph, there's such a wide variety of different configurations. There's not like no 2 Ceph systems are actually the same. So by sharing of performance data across the community and uploading it to a GitHub repo, this could actually be useful across the community for crowdfunding performance data from across the community. So we could all share performance data and all help each other sell Ceph. So what I mentioned about the report generation. So we've developed some significant improvements to the processing of data to generate graphs like you see on the right hand side with response curves. So you can take a batch of results um, and compare it to another set of results from a different run, maybe from a different release, and generate hockey stick curve graphs just like you see on the right hand side. And you'll see some of the slides that from Bill and Alex's talk where we've been using this in anger to generate the results that demonstrate the erasure coding improvements. And another improvement that we've made is generating an intermediate format that converts the IO exerciser to the actual report generation. So one of the main issues is when you add a new IO exerciser, you've got to redevelop the how you generate the report generation. So by generating this intermediate format, then we can easily add support for new IO exercises just by writing a very thin layer that converts the IO exerciser into the intermediate format. So we don't have to rewrite the IO, the report generator. And all reports that we generate are generated in PDF and Markdown format, so they're easily viewable within GitHub. Another thing we've done is by taking a response curve, we can calculate what the high benchmark figure is from the throughput. And so you can generate tables for comparison like this. You can demonstrate for a quick view of what's the percentage improvement is. And although I've only shown actually 2 builds here, but it actually supports up to anyway. Another feature that we've developed, thank you for Jose Perez, where he is in this room, but he's developed a workload which really is the crux of generating this standardized and deterministic approach for doing benchmarking. Initially, it was developed for librd FIO, but we're refactoring the codes so that it's got wider appeal across other benchmark types. So we're currently in the process of refactoring that, so you can use workloads for object, for example. Another thing that we've done is one of the issues with IO depth was that if you use a larger number of volumes, your hockey stick curve, as you increase, if you've got say like 16 volumes, the granularity of each point of the hockey stick still will be by the number of volumes. So you kind of end up this escalating steep incline on the hockey stick curve. So we've developed total IO depth, so it actually fan out, so you can do more fine grained Q depth analysis if you've got a larger number of volumes. And we've also added a script feature so that you can execute a script between each individual point. Now, the useful thing here is it's because if you're measuring the performance of an empty pool with unallocated storage, then it's actually useful to measure as you fill the pool, and also measure populated capacity. So this is actually very useful for measuring the difference between empty versus populated capacity. We're in the process of developing a Ceph ADM configuration generator. That's still work in progress. So this will be inclusion in the report, so you can actually see from the report what the configurations that generated. So futures, currently it's still multi-step. As I mentioned, it's still, we want to go single click. We've been focused on block for erasure coding, but next we'll be doing NVMe gateway and then focus on objects. I'd like to have an interesting from here for the community about object exerciser tools, because some object exerciser tools are more focused towards that particular product. So I'd like to have a conversation with the community about what their preference is for object exerciser. There's a sample of the performance results in my personal repo. A lot of it's the erasure coding. It's all PDF and Markdown format. And we like to add performance over time, to show the minimax performance, histograms, and add CPU utilization, memory utilizations to the reports. Yeah, thank you for your time. Interested in hear your feedback. If you want to get involved in the project with CBT or even try it out even, then contact myself, Chris Harris, and Jose. We're significant contributors. I don't know where they are in this room. Here he is. Yeah. So yeah, come and approach us and have a chat with us. Yep. Thank you for your time.